Hello, welcome back to Statistics and Mathematics YouTube channel. Today I'm going to continue our series of videos on statistical method 1. And then our main focus today will be on discrete probability distributions. Before we jump into the concept of discrete probability distribution, one has to understand what is termed as random variables, discrete random variables, and then continuous random variables. In fact, discrete random variables and continuous random variables are types of what? Random variables. So what is termed as random variable? Random variables are variables whose values are determined by what? Chance, right? Their values are determined by chance, right? It doesn't follow a strict order, right? The values is randomly what? Generated, right? It doesn't follow a particular order, but randomly what? Generated, right? And we are saying that they are represented by block letters like X or Y, right? Yes, they are represented by block letters like X or Y, right? And then we have types of random variables. They are the discrete random variables and the continuous random variables. What is termed as discrete random variable? Discrete random variables has a countable number of possible values. So for discrete random variables, their values can be what? Counted, right? Yeah, they can be what? Counted. And he said let X be a number of chairs in a room, right? This X is what? A random variable, right? And then we are saying that let it be a number of chairs in what? In a room. So when you go to a particular room and there is a lot of chairs there, you can surely count the number of chairs inside that room, right? And then for example, he said let Y be the number of phone calls made in a day. So here the Y here you see here is a random variable, right? So because he said it is represented by X or Y, so he said that would be the number of phone calls one can make within a day. And once the number of phone calls one can make within a day, you can surely count them, right? So they are all examples of what? Discrete random variable. So what about continuous random variable? Continuous random variable can assume all values in interval between any two given values, right? So for them we cannot count them, but they usually lie within what? A certain what? Range, right? They can lie between a certain two what? Range, and it is obtained from data that can be measured rather than what? Counted, right? So here it said let X be a temperature within 24 hours, right? Let X be what? A temperature within what? 24 what? Hours. For temperature they can lie within 24 hours and then you cannot count them, right? Yes, because they are measured. So when you go to hospital, they can measure your temperature, right? And here said let Y be the height of math 153 students, right? And for height, you can't count height. What we do is what? To measure. Right now, since you have been able to get the concept of the random variable, discrete random variable, and continuous random variable, let's dive into the discrete probability distribution, right? So a discrete probability distribution consists of values a discrete random variable can assume and the corresponding what? Probabilities of that values, right? So let me use this example to explain the concept to you. So for this example, it says below is a probability distribution for rolling a single die. So when you roll a single die, what do you think our random variable will be, right? So here our X will be equal to 1 2 3 4 5 6. That will be our X, right? This X is what? The random variable, right? That is the outcome. So when you come here, you see the X at the top here 1 2 3 4 5 6. So here you see the difference. It says it consists of the value of what? Discrete random variable, right? The value that discrete random variable can assume, and then rolling a die to is a discrete random variable. So this is the value that this random variable can assume of rolling what? A die can assume 1 2 3 4 5 6 and the corresponding probability of the value. So right now we are going to calculate or solve for the probability for each of the individual value, like probability for 1, probability for 2, probability for 3, 4 and what? 4, 5 and what? 6, right? So you are going to check for their probability, right? So what's the probability of getting 1 here, right? What's the probability of selecting 1 out of this? We know that probability of an event, right? Probability of an event is equal to number of what? Event divided by a number of what? Sample space, right? So right now we know that probability of getting 1 here is just selecting 1. So number of events is 1 and our sample space is what? 6, right? That's the reason why we had 1 over 6 here. That's the reason why we had 1 over 6 here. What's the probability of selecting 2, right? Probability of selecting 2 still will give us 1 over 6 because out of these total we are just selecting 2, right? We are going to get 1 divided by the total, that is 6. And for this one 3, probability of selecting 3 should also be 1 over 6, 4, 1 over 6, 5, 1 over 6, 6, 1 over 6, right? So that is what is going to happen here, right? So that's the reason why, that is how they used to construct this one, right? Let's go on and solve more example. So this question is also saying that the following table is the frequency distribution for the test score of 100 students in statistics class. Use it to construct a probability distribution. For here we have our S, that is a random variable, and then we have our frequencies for the respective random variable. And then if you can recall, when we started the introduction to probability, I introduced you guys to the types and forms of probability, right? Where we have classical probability, we have empirical probability, and then we have the other one, subjective probability, right? So this is a typical example of what empirical probability, where we said our probability will be equal to, right? Our probability of an event will be equal to f sub I divided by what? N. And this n can also be equal to summation of what? F. You get it? So here, if you want to just calculate your probability, so when you come here, you know that our total is 100. If you want to calculate the probability for s is equal to 0, this is our frequency, right? So here it's going to be what? Probability that our x is equal to 0 is going to be 20 divided by what? 100, of which you are going to get 0.2, right? And then for probability that our x is equal to 1, you are going to get 25 divided by what? 100, because it's the fi divided by what? 100, right? The fi divided by what? The total, and the total here is 100, right? So let's go on and then just go and check the solution, right? So here you are having x is equal to 0, we are having s is equal to 0, we are having x is equal to 0, right? So here we are getting 20 divided by 100, and 20 divided by 100 is going to give us 0.2. You get it? When you come here, you are going to just divide 25 divided by 100, you are getting 0.25. When you come here, 15 divided by 100, you are getting 0.15. When you come here, 10 divided by 100, you are getting 0.1. 20 divided by 100, you are getting 0.2. 10 divided by 100, you are getting 0.10, right? So here we have been able to get our probability. So once we have our random variable here with its respective probability, that is called a discrete probability distribution. And when you sum everything here, you are supposed to get 1. If you sum and then it is greater than 1, then it is not a probability, right? Yes. So there is our probability distribution. You're having 0 related probability of 0.2, 1 with its probability of 0.25, 2 with its probability of what? 0.15, 3 with its probability of 0.1, 4 with its probability of 0.2, 5 with its probability of what? 0.10. So that is what the probability distribution for the question above. Then there is another question here. It says construct a probability distribution for the number of times a head shows up when a coin is tossed twice. Let x represent the number of heads that shows up. So right now they want us to construct a probability distribution where when a coin is tossed twice, right? And then in my previous video, I remember the introduction to probability, I show you guys how we can get our sample space when a die is tossed twice, right? How we can get our sample space when a die is tossed what? Yes, when a coin is tossed what? Twice. I'm very sorry, right? When a coin is tossed what? Twice. So here, when a coin is tossed twice, you are going to get head, tail, tail, head, and tail, right? Yes. So if you don't understand how we got this sample space, please go back to my previous video, introduction to probability, and then go and watch. You will really understand it a lot, right? And then he said you should find the probability distribution for the number of times a head can show up. So within here, the number of times a head can show up, right? We can get 2 heads at the same time. So here here our x can be equal to 2, right? We can get a head, 2 head at the same time. We can get 1 head, right? When you come here, there is 1 head, so we can get 1 head, and then we can get a 0 head too, right? So this is what our sample space. Sorry, this is our random variable. Let's arrange it. We are going to get 0, 1, and then 2. So this is what our sample space, right? And then since it's a probability distribution, right now we have our sample space. So sorry, why am I making mistakes like that? So right now I'm having a random variable that is 0, 1, 2 to be what? The random variable, right? So here I'll just come and I'll read them here. Our x will be 0, 1, 2, right? 0, 1, 2, and then I have to calculate for my probability, right? So what's the probability that our x is equal to 0, right? Probability that our x is equal to 0 is equal to probability of what? Tt, because here we are having only one pair that is not having what? A head. So here, what's the probability of selecting tail out? The probability of selecting tail out will be what? 1 divided by what? 4, because our number of events is 1 here, and then the number of sample space is 4. When you count this one, 1, 2, 3, 4. So our number of sample space is 4, and the number of events is 1 because we are just selecting TT out. So when you divide it very well, we are getting 0.25. And then for the second one, it said probability that our x is equal to 1. The probability that our x is equal to 1 means that we are having only 1 head, and there is 2 observations here that is having only 1 head. So here we are going to get 2 divided by 4 because our number of observation, our number of events will be equal to 2, and then our number of sample space will equal to 4. When you divide it, you are getting 0.5. The probability of that our x is equal to 2 means that probability that we are having 2 hairs. Probability of having 2 hairs here will be equal to 1 divided by 4, right? Which will be equal to 0.25, right? So when we add everything, you are supposed to get 1, right? 0.25, 0.5, and 0.25. When we add everything, we are getting what? 1 to be what? Our answer, right? And then for this one, we said construct a probability distribution for the number of girls of a family with 3 children. And this question too, I've solved it with you in the introduction to probability question, right? How one can get the sample space. So please, if you don't know how to get this sample space, go to this same channel, Google introduction to probability, statistics and mathematics tutor. You will get it, and then you will know how to get this sample space, right? So this is our sample space. It said we should construct a probability distribution for the number of girls of what? A family with 3 children. So for the number of girls with a family, it means that we will get a family with what? 0 girls, right? So here we are having BBB, right? With what? 0 girls. We will get a family with 1 girl, as you can see here. 1 girl, as you can see here, right? And then we will get a family with what? 2 girls, right? 1 girl, as you can see here too, right? We will get a family with what? 2 girls, right? We will get a family with 2 girls. We will get a family with 2 girls. And we get a family with what? All the 3 girls. So here our x, right? Our x can be equal to what? 0, because we have a pair that do not have what? A girl. We have 1, right? This pair is having only 1 girl, and then we have another one having only 1 girl. We have a pair having two girls, right? 2 girls, and 2 girls, right? And then we are having a pair with what? Only all the 3 girls, right? Yes, all the 3 girls. So this one we are having 3, sorry, not 2. We are having 3 girls. Sorry, so 2 girls. Yeah. So when we are doing the selection, okay, when you are doing the selection, that one will be 3. I'm sorry, let me clean it so that we can. So this is 2, right? This is 2. This is 2. So let me continue. Right now, I have my random variable, right? That's the x's. So here you have 0, 1, 2, 3. Left with their respective probabilities, right? So probability that our x is equal to 0, right? So if our x is equal to 0, it means that we are having 0 girl, right? And that one is 1, BBB, right? 0 girl. In fact, the B is representing the boy, and then the J is representing what? Girl, right? So B, right? So here our number of samples, our number of events will be equal to 1, right? Our number of events will be equal to 1, and then the number of sample space, when we count everything here, we are having what? 8 observations. So here number of events is what? 8. So the probability will be 1 divided by what? 8. That's the reason why you see he had 1 divided by 8 here. So you come and write it here. So when you point this on the calculator, we are going to get 0.125. The probability that our x is equal to 1. So if our x is equal to 1, means we are having only one girl. So here we are going to have 1, 2, 3. Right? We're going to get 3 divided by what? 8. Because we know that we are having 3 observations here. Right? 3 number of events here, right? Probably we are going to have only one girl. 1, 2, 2, and then what? 3. So you are having our number of events. We are having our number of events to be equal to 3, and then our number of sample space is equal to what? 8. So here we are going to get 3 divided by what? 8. Right, that's the reason why he had 3 divided by 8 here to get 0.375. And the probability that our x is equal to 2 means that we are having at least 2 girls. So here is 2. So here we are having 2 girls here. 1, 2 girls, 2, 3. So this one we are going to get 3 divided by what? 8 as they had here. And then last one, probably that our x is equal to 3, means that having 3 children. So here I'm going to get 1 divided by what? 8 to be that. So when you add everything, you are supposed to get what? 1. Right? Yes. So that is how it is. And there is some requirements that we have to know for discrete probability distribution. So for here, we have 2 requirements for a probability distribution. First, our probability must lie between what? 0 and then 1. If you have any probability and then that probability doesn't lie between 0 and 1, it means that one cannot be what? A discrete probability distribution. In fact, it cannot be a probability, right? And then when we add all the frequencies, we are supposed to get 1, right? So when you come here, if I add everything here, probabilities, if I add everything here, right, the probabilities, and I don't get 1, it means that frequency distribution is not a discrete probability or distribution, or it's not a probability or distribution, right? So let's solve example here. It said using the probability distribution given to answer the question that follows, right? So this is a probability distribution given here. It said we should find what? A. And just now we have learned that when we sum everything here, it's supposed to be equal to 1. So if there is a letter A here, which is a probability that we don't know, when we add everything here and equate it to 1, and then group like, we are going to get what? Our A. Right? So let's go to the solution C. So here I said summation of probability of x is equal to 1. Right? And then we just sum everything here, 0.5 plus 0.15 plus 0.35 plus 0.8 plus 0.1 plus 0.05 plus 0.0 plus 0.2. When we add everything here, right, you are going to get, when we add everything here, we are supposed to get 1. So you add 0.15 plus 0.35 plus 0.10 plus 0.05 plus 0.2. You are going to get here to be, you are going to get A plus 0.85, which is equal to 1. So since we want A, we have to group like term. We are going to get 1 minus 0.85. That's the reason why I had this one here. I have to group like term, and our final answer will be what? 0.15, right? Because when you subtract 0.85 from 1, I'm going to get 0.15, right? Yeah. So here our A is equal to 0.15. So let's go to the second question. It said find the probability that our x is less than or equal to 2, right? So we want to find, they want us to find the probability that our x is less than or equal to 2. So if our x is less than or equal to 2, it means that you should find probability that our x is less than or equal to 2. It means that our probability that our x is equal to 0 plus probability that our x is equal to 1 plus probability that our x is equal to what? 2. Because they want us to sum, right? If our x is less than or equal to 2, it means that we are supposed to end here. So you are going to add everything from 0 to what? 2. So here you are going to get 0.15 plus 0.35 plus 0.15, because we know the A to be what? 0.15. So when we come to the worksheet here, that's what the worksheet is also giving us. 0.15 plus 0.35 plus 0.15. We are getting 0.615 to be what our final answer. There is a lot of questions here that they want us to solve. He said, determine whether each distribution is a probability distribution. Right? Note, a distribution can be a probability distribution if and only if the probability of x lie between 0 and 1, and a summation of the probability of x is equal to 1. Right? So this is the principle that we are going to use to determine if this is indeed a probability distribution. First, we have to check if probability of x lie between 0 and 1. We could see clearly that 1 over 4 is within 0 and 1. 1 over 8 is within 0 and 1. 1 over 16 is within 0 and 1. And then 9 over 16 is also within 0 and 1. So we have to add them together and see if indeed they are equal to 1. If they are equal to 1, then they are indeed a probability distribution. So let's add the probabilities together and see if it's equal to 1. So when you add everything, it's surely equal to 1, right? When we add 1 over 4 plus 1 over 8 plus 1 over 16 plus 9 over 16, we are getting what? 1. So here, the individual probabilities, they are within 0 and 1, and the summation 2 is equal to 1. Then we can say that the A is what? A discrete probability distribution. What about the B? For the B, you could see clearly that probability that our x is equal to 0, we are having negative 1.0. Right? Since you are having negative 1.0, strictly this is not what a discrete probability distribution, because, or this is not a probability distribution because for probability distribution, you are saying that the individual probabilities must lie between 0 and 1, and this one is a negative. It doesn't lie between 0 and 1. So this one, the B, is not what a discrete probability distribution, right? So let's continue to the C. Right? For this one too, we are saying that first you have to check if the probabilities lie between 0 and 1, and then we could see clearly that here they all lie between 0 and then 1, right? So the first assumption is gone. What about the second assumption? Summation of p of x is equal to 1. It means that when we sum everything here, it's supposed to be equal to 1. So 1 over 5 plus 1 over 5 plus 1 over 5 plus 1 over 5 plus 1 over 5. We are getting 5 over 5, which will be equal to what? 1. So we can say that the C is what? A discrete probability distribution. What about the D? We are having 2, 3, 7 to be the random variable. And here we are having 0.5 plus 0.3 plus 0.4. When you add everything here, we are getting 1.2. Of it, this one, the summation exceeds 1. So here, this 2 is not what? A discrete probability distribution. So there's the end for the discrete probability distribution. Yes, in our next video, I'm going to discuss the mean and variance for discrete probability distribution. So please kindly stay tuned so that we can learn together. Bye. Have a great day. Don't forget to subscribe to Statistics and Mathematics YouTube channel. Bye.